Happy end of spring break. All right, so we are starting transformations and symmetry, and some of this stuff may seem like a foreign language, so just FYI. So please, well, I guess soon we'll all be together, so you won't have a chance to not take the notes seriously, but here we go. All right, so this stuff is, again, just notes that we need. Make sure this is over the X, different degrees in rotation. So if you go 90 degrees, got to remember if it's clockwise or counterclockwise. This is going to be the same regardless, but this is going to be 90. So if you go the other way, it's going to be the opposite. So we'll get those straightened out. And then the reflection. And this one can change, so just make sure that's what this one looks like. So this one's over the Y, this is over Y equals X, and sometimes those will change a little bit. Okay, so let's jump into this. I think this first section is pretty easy. So we'll start with this vocabulary, which you may already know. So your line of reflection is just that line of symmetry. So it is a line in which each point on the old image, we're going to go over that, and its corresponding point on the new image are the same distance. Okay, so again, the pre-image is the old before the transformation. The image is the new or after the transformation. I know, probably doesn't make sense, but here we go. Also, you guys already know this, I believe, that this A prime, this is said to be as A prime, which is your movement. Sometimes they'll have A prime prime, which means it's a double movement. Okay, so here is just a reflection of a line. So you're just reflecting. If the point is on the line, then the image and pre-image are the same point. If the point is not on the line and the line is the perpendicular bisector of the segment joining the 2 points. So I think that is just information, just there it is. Okay, so here is the good stuff. So if you took 8th grade math, you would have this, but you guys did not because you guys were in pre-algebra. So these are reflection, and when it says in the x-axis, I always think of it over the x-axis. So what they're saying is these 2 points here and here are the same distance. From here to here are the same distance. Reflection, it is the flip. And then here it's over the Y. So maybe I should, this is over the X and this is over the Y axes. And these are the rules. These are going to be very handy. As a matter of fact, you might want to highlight this so you see that quickly. This seems very bright. I wonder if I should tone this down. Oh my goodness, so much better. Perfect. Okay, so that's that information. This is where you are hold on just a sec. This is where the Y equals X. So this one's the more complicated one. So it's good to have the exact rule. So this is kind of an oddball, but here's the rule for that. What's great about this is you write down your original points here. The original, because these are the primes, these are the movements. Anyway, and so you're just flip-flopping. If your X was here, it's now going to be backwards. So you're just going to flip-flop those to get your answer. Again, This is the same thing we just went over. These are those rules again. I don't know why they're double, but here you go. Here are the rules. Sometimes it's good to have them all. So here's that line of reflection. Again, rules, rules, rules. Okay. So use the figure in the given line of reflection, then draw the reflected image, this line, using a ruler or straight edge. Well, what we're going to do, I guess I could use my ruler or my straight edge to be exact, but we cannot use a ruler and just write it. So basically what we're saying is that this has to be the same distance here. So we're going to say that's A prime. We're going to say that's the same as that. This distance would be the same as my B prime. So same distance, same distance. And the same thing with the C, which is hard to do. So we're just going to, and that's a little further over, and we'll bring him up. So this is about your C. Now, if you had a ruler, you could be more exact. Doot, doot, doot. So that is my reflected image. Okay. I guess if I did a ruler, it would have looked a lot nicer. Moving on. Now, it says, here's a quadrilateral with these vertices, and its image reflected in the x-axis. So let's go back to the rules for the x-axis. I'll write it out above here. It says to the x-axis, we're going to change our x and y values to x negative y. So for me, I always like to write these. So A is 1, 1. B is 3, 2. C is 4, negative 1. And D is 2, negative 3. Now we're going to rewrite that using the rules. So my x stays the same and my y value changes to its opposite. My x stays the same, my y changes to its opposite. X stays the same, my y changes to the opposite. My x stays the same, my y changes to my opposites. So now I can graph both of these easily. Done. I'm going to move on. You can graph them. Next, same thing. This time we are going to image under the reflection of y equals x. Y equals x. So that rule was you're changing your xy to, I think it's just a flip-flop, wasn't it? Y, x. Okay, so my A is 1, 1, B, 3, 2, C, 4, negative 1, D, 2, negative 3. The rule says I'm going to flip-flop, so he's going to stay at the same place. 2, 3, so I'm just reversing these. Negative 1, 4, negative 3, 2. It's kind of easy to look at the rules and do it. Sometimes it's easy to reflect them, and this one is the hardest one, so I really recommend that you do this on this one. This one up here, you can probably do the reflection across the x or the y. That should be easy because of the equal distance thing. This one is a little different. Because it says y equals negative 2, this is going to be your line of reflection, this right here, and not, I think I just did that wrong, and not, no, that's right, because that's y, negative 2, and not the x-axis. So this is the point, this is a line y equals -2 looks like this. It goes through the y-axis at -2. So that's going to be my line of reflection. So this one's going to be a little different. So we're going to go ahead and graph this one. So my original, let's see, J is 2, 3. Okay, so for my L, I know it's going to be L prime here because it's the same distance here. And my K, 1, 2, 3, 4, so 1, 2, 3, 4. My J, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. M, 1, 2, 3, 1, 2, 3. M prime. All right. So that shows that reflection, that flip over -2. So let's look at L2. So let's look at original L. So it was 2, -1. And now we are at 2, -3. So what happened? We literally just took away 2 from the y value. And I was just trying to think of how we could look at that rule. Over the x, over the y. Where's the over the y rule? Let me go back to look at that. So the opposite. So truthfully, the rules didn't really help you on this one as much, but I kind of wanted you to see that pattern and kind of what happened here. So on this one, I'm going to do it again. So on K, let's just look at that one. K was 3, 2. I like to look at patterns, so I'm just getting nerdy here. And then what happened to K here? 1, 2, 3. That stayed the same. So this became 1, 2, 3, 4, 5, 6, -6. So what happened? Here to here, we decreased. From here to here, it really decreased. So again, you cannot always just use these rules. You've got to know how it works as well without the rules. Know the rules without the rules, especially if this is thrown in here. Okay, I think that's all for this. Is it? Yeah, that's it for this section. We're going to start doing one day at a time just because we're going to start going back to that when we're all together. So you can go ahead and start on your assignment.